this video, I'm going to be talking about when you're going to see slant asymptotes in rational functions. So sometimes rational functions, we said they didn't have horizontal asymptotes to describe their end behavior. Well, sometimes if they don't have a horizontal asymptote to describe the end behavior, they will have a slant asymptote. We also call slant asymptotes, another word that we use to talk about it is they're also called oblique asymptotes. Oh my gosh, I can't write. Called oblique asymptotes. So just keep that in mind if you see it on a test. It's talking about slant asymptotes. I have a function, f of x is equal to n of x over d of x. We talked about before, it's some polynomial over another polynomial. And another way we can write it is we have some coefficient and x to some power n plus a bunch of other stuff all over b, another coefficient times x to the d power plus other stuff, where n and d are the highest powers. So n and d are highest powers in the numerator and denominator. Okay. Using that general form, we're going to talk about when we're going to see a slant asymptote. So we know that if n is greater than d, there is no horizontal asymptote. And there will be a slant asymptote if n is equal to d plus 1. So if the highest power in the numerator is 1 higher than the power in the denominator, then I know I'm going to have a slant asymptote. So a diagonal line asymptote instead to describe the end behavior instead of a horizontal line describing the end behavior. So if n is equal to d plus 1, then the graph will have a slant or oblique asymptote. Then the graph has a slant asymptote at y equals q of x, where q of x is the quotient from the division of the actual fraction that we have. So from the long division of the fraction that we have, n of x divided by d of x is what we're going to actually do. You will only need to check for a slant asymptote if there is no horizontal asymptote. So to keep in mind, if you have a horizontal asymptote, you will not have a slant asymptote. Only one thing is going to be able to describe the end behavior on the left and the right, either a horizontal line or a slanted line, not both. So you only need to check for a slant asymptote if there is no horizontal asymptote, or n is greater than d. The highest power in the numerator is greater than the highest power in the denominator. All right, let's do an example. So I want to graph the rational function f of x is equal to x squared over x minus 2. First thing I would want to do when I was doing this, like we've done before, is I would want to factor this thing if I could, but I can't, so I'm going to leave it like that. I mean, I could rewrite this as x times x in the numerator, but I don't need to do that. So I'm going to look for, first we look for the discontinuities and we start with holes. Is there anything that cancels in the top and the bottom? No, so there are no holes. Then I look for the other discontinuity, which is the vertical asymptotes. I'm looking in the simplified fraction. This is the simplified fraction, my original fraction. I can't simplify it, so because nothing cancels, so I look in the denominator to see what x value would make the denominator 0, because then the fraction would be undefined, so I can't have that x value, and that x value is 2. So I know I have a vertical asymptote at x equals 2. The line, make sure you're writing the entire line. Then the next thing I'm looking for is if I have a horizontal asymptote. So obviously we're talking about slant asymptotes, so we probably don't have a horizontal asymptote, but let's just check for kicks. I have x squared over x to the first power. Those are the highest powers in the numerator and denominator. I can see that n is greater than d, which is 2 is greater than 1, right? So now I want to check, does it have a slant asymptote? Well, it's going to have a slant asymptote because n has a slant asymptote because n is equal to d plus 1. So I see that this is, the power in the numerator is 1 higher than the power in the denominator. So the power in the numerator is 2, the power in the denominator is 1. This statement is true. 2 equals 1 plus 1. Okay, so no horizontal asymptote, but I do have a slant asymptote. So slant asymptote, yes. And what is it? Well, we're going to have to do long division to find what it is. So on the bottom here, we have some space. I'm going to do the long division here. I'm going to write long division. So I'm actually going to divide the numerator by the denominator. So the numerator is x squared, and I'm going to divide by x minus 2. When I'm doing long division, think back to algebra 2, I want to include all the powers from the highest power down to the lowest power for both the thing on the outside and the thing on the inside. I do not have the powers less than 2 inside. I do have x to the first power and then x to the 0th power on the outside, so I'm good. I included all my x powers down to the constant. So x to the 0th power would also be a constant term. I need to include those things here inside. So I have x squared. I'm going to write plus 0x to the first power, or 0x, plus 0x to the 0th power, or just 0. Just to keep everything in a tidy line so I don't make any mistakes. Then I'm going to ask myself, what do I have to multiply x by to get x squared? And I have to multiply x by x to get x squared, so I put an x in the top there. Then I want to see what have I taken care of already from this thing that I have inside. And in order to do that, I need to multiply x times x and x times negative 2. I needed to make sure I'm distributing that x to both terms that I have on the outside. So I have x times x gives me x squared, and then I have x times negative 2 gives me minus 2x. I know this is what I've taken care of so far, so I can subtract it from the total that I started with inside. And after that, let me just erase this. I'm going to see that I have, gotta lower that eraser. I'm going to see that I have left over x squared minus x squared gives me nothing, 0, so I don't write anything. And then 0x minus negative 2x is actually 0x plus 2x, so I have 2x left over to take care of. I'm going to bring down the 0, so I'll have 2x plus 0, and then I'll keep going. So the next question I ask myself is, what do I have to multiply x by to get to 2x? And the answer is 2, so I put a plus 2 up here. I multiply 2 times x and 2 times negative 2 to see what I've taken care of. 2 times x is 2x, 2 times negative 2 is negative 4. I'm subtracting this amount because it's what I've taken care of, and I want to see what do I have left over to take care of. 2x minus 2x is 0, 0 minus negative 4 is 4. And then I ask myself again, what do I have to multiply x by to get 4? There is nothing that I can put up here, which means that 4 is my remainder. So my answer for what q of x is, because that's going to be how we represent the quotient, I know that my slant asymptote is going to be y equals q of x. And in this case, what that is what I have on the top, x plus 2. Oops. So I have x plus 2 plus the remainder, which is 4, all over, I still need to divide that 4 by x minus 2. So I write 4 over x minus 2. We only want y equals mx plus b form, so we only want these first two terms. We do not care about the remainder. This piece here, we can ignore, so we ignore this. We only want the line y equals mx plus b. So we want our constant, and we want our x term. And so we're only focusing in on, once we get a constant up here, we can just stop. We don't have to go any further. We need an x term and a constant in the form y equals mx plus b. So my slant asymptote I know is y equals x plus 2. And I rewrite that. Now in pre-calc, we talk about it as end behavior. So we say the limit as x goes to positive or negative infinity of f of x is equal to x plus 2. I'm going to start now putting everything in. So this is my end behavior. It's going to be a diagonal line instead of a horizontal line, like we've seen before. All right. I'm going to start graphing these things that I have. I don't have a whole. I have x equals 2 is my vertical asymptote, so I'm going to put that in. Okay, this is x equals 2, my vertical asymptote. Then, what did I forget? I forgot to do if I have here, I was supposed to see if I had a y-intercept and if I had an x-intercept. So y-intercept, I am plugging in f of 0 and seeing what I get. If I plug in f of 0, I'm going to have 0 squared over 0 minus 2, which gives me 0. So that means my y-intercept is the point 0, 0. That means I also have an x-intercept at 0, 0. Let's see if that's the only one that I have. Well, to find the x-intercept, I'm setting the numerator x squared equal to 0 and then solving for x to see when the numerator would be 0 for what x terms. The only x term that it would be 0 for is 0, so my only x-intercept is 0, 0. If this is a y-intercept, it's also going to be an x-intercept as well. Both terms are 0. So I have a y-intercept or x-intercept at 0, 0 that I'm going to put on the graph, and then I'm also going to draw my slant asymptote, which is y equals x plus 2. So I'm just going to draw a dotted line. I'm going to start at my y-intercept, which is 2, and then I have a slope of 1 over 1, so I'm going up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and I'm just going to draw this dashed line, up 1 to the right 1. And I'm going to continue that pattern the opposite direction as well. So left 1, down 1, left 1, down 1. Oops. And this is what my line will look like. So this is my slant asymptote. And I'm going to draw in the rest. So this is a point that I have, an important point that I have. And I'm going to use that to graph the other points. As I go to the left of this point, I know that the end behavior is described by that slant asymptote, so I'm going to be getting closer and closer to that slant asymptote as I go to the left, as I go to x's negative infinity. As I go to the right, I cannot go through a vertical asymptote, so I'm going to get closer and closer to that vertical asymptote. If I want to know a point in the top section here, I'm going to pick a value to plug in, and because I don't have any of my important points, I don't have my y-intercept or x-intercepts in that location, so I'm just going to pick an x value to plug in, and I'll do anything to the right of that vertical asymptote. So let's do 3. So if I do f of 3, I'm going to have 3 squared over 3 minus 2, which gives me 9 over 1, or 9. So I have the point 3, 9 that I'm going to add to this graph. 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. And as I go to the left of that point, I know I'm getting closer and closer to the vertical asymptote. And as I go to the right of that point, I know I'm getting closer and closer to that slant asymptote that we drew. And that's what my graph will look like. Let's try another example. So example 2, I want to graph the rational function f of x is equal to 2 plus 3x minus x squared over 1 plus x. The first thing that I want to do is I want to rearrange what this looks like so that I have the highest power first. So I'm going to write negative x squared plus 3x plus 2 over, and then in the bottom, I'm going to rewrite this as x plus 1, just because I like to look at it that way. It's easy to make a mistake if it's not written that way. So I would advise that if you see it that way, you change things to be in the order, in standard order from highest to lowest. Right off the bat, looking at this, I can see the highest power in the numerator is 2 and the highest power in the denominator is 1. Since the numerator power is 1 higher than the denominator power, I know that there is going to be a slant asymptote here. So I know there will not be a horizontal asymptote. And now I'm going to go through all the things. So first thing is there a hole? I don't know. I didn't factor this, so maybe I should factor it first to see. I'm going to, maybe I'm going to take out the negative. So I'll take out the negative and I'll rewrite this as negative x squared minus 3x minus 2 all over x plus 1. And is there anything that I can factor? So I need two numbers that multiply to negative 2 and add up to negative 3. And I can't think of anything. So no, I can't factor it. So I'm going to leave it as it is. And because I can't factor it to have, and I know x plus 1 is not a factor, or I would have been able to factor it. So I'm going to say none for holes because nothing cancels. Then I'm going to look if there's a vertical asymptote, and there is at the x, where x is negative 1, that fraction is undefined, so x is negative 1 is my vertical asymptote. I know that there is no horizontal asymptote because there's a slant asymptote. So none for horizontal asymptote. Then I'm going to do, what's the slant asymptote? So at the bottom, I'm going to do long division. So I'll do long division. And I'm going to do, I have negative x squared plus 3x plus 2. And I'm dividing it by, I should just move this a little bit. I'm dividing it by x plus 1. How many times does, or what do I have to multiply x by to get negative x squared? And the answer is negative x, so I put a negative x up here. I make sure I'm distributing when I multiply to both the x and to the 1 to see what I've taken care of so far. And that is negative x times x is negative x squared. Negative x times 1 is minus x. Remember, this is what you've taken care of, so you want to subtract it from the total. And so you're going to be left with negative x squared minus negative x squared is 0. 3x minus negative x is 3x plus x, which is 4x. And then I'm going to bring down that plus 2. And then I'm going to ask myself, what do I have to multiply x by to get 4x? And the answer is 4, so I put a plus 4 up here. I literally don't have to do anything else. Look, I have my y equals, this is y equals mx plus b form. Okay, that's mx plus b by itself. You don't see the y there, but so I can say that my slant asymptote is y equals negative x plus 4. And I actually write that the limit as x goes to positive or negative infinity of f of x is equal to negative x plus 4. So remember writing it in this notation when you're talking about end behavior, slant asymptotes or horizontal asymptotes. Okay. I'm going to draw this stuff. So I have x equals negative 1 is my vertical asymptote, so I'm going to draw that in. Then I have my slant asymptote is at on the line y equals negative x plus 4. So I'm going to go up to 4 and draw my y-intercept and then use the slope. So as I go to the right, it's down 1 to the right 1. And I'll just put the dashes in. Down 1 to the right 1, down 1 to the right 1. And I will put all of these in and go backwards as well. I can see that this is a downwards line, so it makes sense it has a negative slope, just to check myself. And then I'm going to start putting the important points in. Well, I didn't do them, so I'm going to try to see if there's a y-intercept. I'm plugging in 0. All of these terms are gonna, whoops, these terms are gonna go away, this term is gonna go away, and I'm gonna be left with 2 over 1. So my y-intercept is 0, 2. So y-intercept is 0, 2. And let's see what's our x-intercept, or our x-intercepts. I'm looking for when this up here is equal to 0. So when negative x squared plus 3x plus 2 is equal to 0, you would actually have to use the quadratic formula or your calculator, but you won't have your calculator on the test. So you would have to use the quadratic formula if you ran into a case like this where this thing on the top wasn't factorable, so I couldn't factor the left-hand side. And the quadratic formula, if you forget it, is my x-intercepts is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so when I plug that stuff in, I'm going to have negative 3 plus or minus the square root of 9 minus 4 times negative 1 times 2 all over 2 times 1, or 2 times negative 1, which is negative 2. And then if I simplify that, it's going to be 3 plus or minus the square root of 17 all over 2. And if I do that in a scientific calculator, because you're allowed to have those, you would get 3.5, well, about 3.6 actually, comma 0, and negative 0.6 comma 0 as your x-intercepts. And then I would plot those. So I have 3.6 comma 0 like right here. And then I would also have negative 0.6 comma 0 like right here. And then my y-intercept at 0 comma 2. I can see that I'm gonna have a curve as I go to the left. It's gonna get closer and closer to that vertical asymptote that I can't go through. As I go to the right, I'm going to get closer and closer to my slant asymptote, because as I go to x is positive infinity, I will be getting closer and closer to that slant asymptote. And then to find another important point in this section here, well, there would be another piece of this graph. I'm going to pick an x value to the left of the vertical asymptote close by so it can fit on my graph, and I'll pick negative 2. If I pick negative 2, I'm going to have 2 plus 3 times negative 2 minus negative 2 squared all over 1 plus negative 2, which will give me 2 plus negative 6. Negative 4 plus, it will give me negative 8 over negative 1, which is 8. So negative 2 comma 8, 1, 2, 3, 4, 5, 6, 7, 8 right here. As I go to the right, I'm going to get closer and closer to the vertical asymptote. As I go to the left, I'm going to get closer and closer to that slant asymptote, and that's what my graph is going to look like.